Are you able to hear me?
Yes, I can hear you.
Can you see my screen?
Yes, I can see your screen.
All right, so let's get into it. So with the, you already know what the select statement does. The select statement is kind of like, let me say, a print statement in a standard programming language. You're just getting, you're just able to fetch information and then you display it, right? Okay. But then there's also a way to filter the information that you get. Now, for example, let's say that I have a maybe a table of students, for example, and there's an address column, and I want to find out all students who stay in Sandpit or all students who are based in maybe in Yaoundé or in Douala, right? I'll now have to filter. What you were doing up there was ordering. I think you looked at the order by clause, right? Yes. You look at
Yes,
the order by clause where you're just returning data either in ascending order or in descending order, depending on the specifications that have been given. But yeah, we want to filter. And in order for you to retrieve rows from a table that meet a particular condition, for example, maybe students who stay in Boya, right? We must make use of the where clause. Let me zoom in a little. We have to make use of the where clause. And this is the syntax. So you do your select statement still and you specify your select list, which can be a list of columns, right?
yes,
Okay. And it can still be a single column. And then you specify the table that you're selecting from. So you're saying that, okay, from this table, I want to get all of this information where this condition is met and I want to order in this manner. Okay, so this is the syntax. Now, in this where clause, right, you have this condition. What does condition mean? Condition here is always a Boolean expression that will evaluate true or false. So take for example, I'm looking for maybe students that are based whose address is in Boya, right? Okay, if I actually have a result, then it means that okay, this is true. Send me all those students. If there's nothing, then it is false, right? So it either evaluates to true or false. Okay. And the query, when you make use of this where clause, will only return rows that satisfy that condition, meaning that when that condition evaluates true. So the order of execution in the where clause, when you're using the where clause, is as follows. Okay, from let me say the students table where address is Boya, select first name and last name, and order by first name. That's the order of execution. That's how the query actually runs in the background. So it doesn't even start with select, it actually starts with from. Like, okay, what table do I want to pick this information from? Okay, so yeah, it says that you should note that column aliases, if you want to use column aliases in the select clause, you cannot use it in the where clause. Just like maybe you used it here in order by. I'm sure you saw all of that. Now,
yeah.
the question is, the question is why? Why can't we do that? Because of the way this order of execution is. Okay, take for example, if you say select, normally forget about the where clause now. If you take, let's say, select um, first name as giving name, for example. So your alias says giving name, right? You can now come and still use that giving name alias in the order by clause. Why? Because order by comes after select. So it would have knowledge. How does this keep happening? It would have existing knowledge of that alias, but then the where clause comes before the select clause. So if you use an alias here, it doesn't even know what you're talking about. So in the where clause, you must use the actual column name. We're going to see how all of that goes. Then we also have operators that you can make use of in the where clause. Let's say you had an employee table and that employee table also has information on salary. So there's a salary column, right? You want to get maybe all employees who make exactly 500K. You are going to say where salary is equal to 500,000. Okay. Then maybe you want to know employees who make above a certain range, above a certain amount. Let's say employees who make at least 150,000. At least in mathematical terms is the same as saying greater than or equal to, while at most is the same as saying less than or equal to. So you're going to be saying that, okay, if I want to get people, if I want to get employees who make at least 150,000 francs, I'm going to say maybe select first name, last name, and salary from employees, where salary, that's the salary column, right? Where salary is greater than or equal to 150,000. So these are other operators you can use here. There are also logical operators and or in. You saw all of these in foundations, right? There's also
Yes.
between. Great. There's also between. So between, just as the word is, that's how the clause. Between, you're looking for something that is maybe inside or in the middle of this and that, right? Same way that it works here. So it returns true if a value is between a range of values. Okay. Same thing even with the salaries. Maybe you want to know people earn between 100,000 to 300,000, for example. You just use a between clause. You just make use of the between clause. And then like is for pattern matching. We're going to see all of these. Like is for pattern matching. I want to get all maybe customers whose first name starts with an L, right? Or who have the last name. Maybe our business is maybe centered around something for families, and we're giving a discount, right? So we want to give a discount now specifically to the Tambe family, right? Or to the Agbo family. And okay, now we want to get all customers who have last name, who have the phrase, sorry, the word Agbo inside their name. So that's a pattern that we're matching. We can make use of like. There's also I like. The difference between like and I like is that one does case sensitive matching, while another one does case insensitive matching. So when I talk about case, let me pull out my text editor so we can have some examples. Okay. So when I talk about case sensitive and case insensitive matching, this is what I mean. So let's try to visualize. Let's say we have a customer table, right? And in the customer table, we have ID, we have first name, we equally have last name, and then some other information, say like address. Now in here, okay, we have Loved, and this is his name. We also have let's say Anna, but Anna's last name is Ashu, and she's based, let's say, in Douala. But then we have someone called maybe Kit, and Kit is also an Agbo, right? But then we have someone that for whatever reason, this is how his parents gave his name. Maybe Frank Agbo as his first name, then um, Tambe as last name before address, Yaounde, and so on. So now with like, right? If you want to get people whose last name, let's say, okay, let's put that there. Let's also have this. I'm picking out all Bayangi names now. Let's also have Abuno. Great. Okay. So now, if you want to say that I want all employees, all customers, sorry, whose last name contains Agbo, right? I'm going to say, okay, select first name, last name, and maybe ID, right? From customer table, from customer, Now I'll come and use this in the where clause. I'll say where last name, like, I'll now put it in quotes like this, and I'll use this percentage and say Agbo. Now let me explain what this percentage means. Okay, so this percentage, I'm saying that there could be zero or more characters before the text Agbo, and there could be zero or more characters after the text Agbo. I don't care where it is found, right? I just want to know that okay, there is Agbo inside here. But then what happens if I remove, let's say, this percentage before Agbo? It means I'm saying that the last name must start with the string Agbo and then end with anything else, zero or more characters after Agbo, right? Is it big enough?
Mm-hmm. It's big
Okay,
enough. Yes.
all right. And then end with zero or more characters. But then what if um okay, what if what is this going to pick? It's going to pick, let me see, it's going to pick Anna, but it's not going to pick sorry, it's not going to pick Anna. It's going to pick, yes. These lines are confusing me. It's going to pick Keith, right? Because Keith's last name actually starts with Agbo and then ends with zero or more characters of whatever string. But Lovett is also Agbo, right? But then the difference here is that in this column, his last name does not start with Agbo, so it's not going to pick him. You understand? But if we put this here, we're saying that even if there are 2 million characters before the text Agbo, if Agbo is in this last name column, give me this result. Now, what happens if I remove this one at the end? I'm saying that, okay, it can begin with, it can begin with anything, right? But it must end with Agbo. Meaning what? Kit is not going to be, what do you think? Is Kit going to be picked out? Kit
Yes.
and Loved. Yeah, they are going to be picked out. But let's say we had a case where let me interchange this. Okay, let's say we just had this. What's going to be the result?
It's going to display every all of the full line where Akbar is, the full column, like the kids, Akbar, Abuno.
Mm-hmm.
Yes.
To
Or
also display this and
yeah.
display this, right?
Yes.
But then we're not matching any pattern here since we're just saying that it must be this exactly. So instead of writing it like this, if you want to write something like this, right, you should rather say where last name is equal to Agbo. After all, that's direct matching, right?
Yes.
Okay. Now, the difference between like and I like. You see here now with I like, right? With like, right? What will happen is that it's going to look for everybody here whose last name is written in this specific format. So if you have maybe your name here in capital letters, it's not going to pick you. Why? Because it's doing a case sensitive match. If maybe this person had this, it's still not going to pick them because it's doing a case sensitive match. But then if we used I like is case insensitive. It still does the same pattern matching there, just that it's case insensitive. So with I like, it's just going to look for everybody who has Agbo, whether it was written or in capital letters, whether it was written in small letters, like in whatever case, if the case was mixed, it's going to get Agbo irrespective. Do you understand?
Yes. I want to
All
ask
right.
something about the syntax. Is it
Yes.
okay for the last name to have a comma?
Where, yeah.
Yes.
This is the last column you're selecting. If you put a comma, it's going to throw an error.
Oh, okay.
If you put a comma, it's going to throw an error. Let me see. I don't have. It's not good. I've still not loaded that database. That DVD rental database, but then we can create something. So PG admin is opening for me, but while it's loading, let's continue. Okay, same thing for the salary. Let's say, um, now let's say this is an employee table, employee table, and then over here we had their salary, right?
Yes.
So Lovett is the richest person here, earning $1 million. Cannot be CFA. Okay, and then followed by Anna. Anna has not been so hardworking. She makes just 200K. This other person makes maybe 500. One, three. Okay. And this other person, God knows what he does at this company, but he's paid 50K. Okay. So now let's say you wanted to get all employees who earn at least 200,000. You're expecting to have all of these three people, right? How is
Yes.
the query going to look like? Guide me. Let me write it.
We are going to make use of the operators.
Mm-hmm.
Um, excuse me.
All right.
Mm, okay.
Mm-hmm. So what's going to be my wear clothes?
Um, select IG. Okay. You said all employees from 200K and above.
Yes, from 200K and above.
Where um salary as amount and
No, 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 no. This one is just an alias for how it will be displayed, right?
okay.
So we don't need to copy it back. Now in the word clause, you just use the column name, the actual column name. Yes,
It's okay, greater than equals to is uh greater than or equals to
two
200.
hundred thousand, right?
Yes.
Great. All right. That's okay. That's how it is. That's how it works. Okay, and then following this, so the approach that we've even been using to learn the SQL, I don't give the solution. You just need exercises. So following this, there are exercises for you to do. Let's go over each and every one of them. So since you have the database, share your screen. Let me try setting it up on my end.
Okay, let me connect my laptop.
All right.
Live streaming is on.
Okay.
Yes, I'm seeing your screen.
Mm. So let's begin with the first exercise. Okay, from GVT rentals. Okay.
Okay, yes, this is good. So you understood the question. Instead of using like or I like, they have already told you that their first name must be Jamie specifically, right?
Yes.
So you just use equal to, which is fine. Okay, but then if you wanted to do a case insensitive search for Jamie, for first name being Jamie, how would you write it?
For case insensitive.
Yes. So if someone had maybe Jamie all in capital letters, all in small letters, how would you write it?
Okay, first I know that I'll use I like.
Yes. So write it, let me see.
Okay. I'll just tell you step one.
All right, I've heard step one. Next step.
Excuse me. I'll write it like this.
Okay, let me see. Yes, that's good. Although the I can be in capital letters, remember the I then I like can be in capital letter.
Okay.
The language is also case insensitive, but then stick to one case.
All right.
Okay, so let's look at the next exercise. Try to do the next one. Fetch the customer whose first name is Jamie and last name is Rice.
I've done it.
Let me see. Have you run the query?
No, I've not run any.
Okay, run it to the result.
Okay, I've run it.
Nice. All right. So take the next exercise and do write a query that gets all customers whose last name contains Rodriguez or first name contains Adam.
Mm.
And Love, by the way, just to make your query more readable, right? Since this and operator is being used in the where clause, if you don't want to put it on one line, put the cursor there, yes, where you are, before and click there and then press tab.
Um, Click it and press.
Press tab, the tab button.
Okay.
Yes, so now it looks more readable. You know that all of that is under the where clause. So go to the next exercise, question 3.
This is what we're talking about with the um
The word
using percentages.
using,
A percent, the percent.
yes. Whose last name contains, okay, you see the language now is different. Not instead contains. So yes, using percentages to represent zero or more characters.
I've done it.
Okay. So they said write a query that gets all customers whose last name contains Rodriguez, yes, or the first name contains Adam. All right, that's good. Your solution is correct. So move to the fourth exercise. Okay, I'm seeing what you're doing. So you said the DVD rental company wants to do a giveaway for any client who has a derivative of the name Anna. And so using the in operator, get all clients whose first name are either Anne, or Annie. Yes. So you see here that when you make use of the in operator, it prevented you from having multiple lines or multiple statements that had the or operator, right? Maybe instead of you coming to write where first name equals an, or first name equals an, or first name equal and you just make use of the in operator, right? Love it. Are you still with me? I see you red for your network.
I've done it.
Were you able to get anything I said?
No, your lines were breaking. I
Okay,
was
I was saying
renewing
that.
my connection.
Oh, okay, then that's fine. I was saying that you see here that using the in operator prevented you from having multiple statements with the or operator, right?
Yes.
Okay. So let's move to B or B.
Using like.
Yes.
I've done it.
Okay. And our customers whose first name starts with the word and. Yeah, that's great. So question, although I know you already know the answer, what is the difference between the like and I like operators in Postgres?
I like is case insensitive, while like is case sensitive.
Yes. All right. Let's move to the fifth exercise then.
I have a question.
Yes.
When it comes to measurement, is like the the quantity. Can I just write it like that, like width or
Come again.
diameter?
Let me see the question. Let our customers in the table in the DBO's first name start with the letter A and contain 3 to 5 characters using the between operator. Okay. So what's your question?
Okay, like they've said first names starting with A and containing 3 to 5 characters. So in the character, I'm obviously I have to measure now. So can I just implement the language of the measurement in this database, like white, like maybe white last name
Write what you're
between.
saying. Let me see.
Okay. This is what I'm saying.
Run and see the result.
Oh, it worked.
Okay, love it. So whenever you're in doubt of something, do it and see what happens. That's part of the learning process. So let's continue. Finish all the exercises so we can move to the next part.
All right.
All right, so I just realized that in the previous exercise that you did, it specified that you had to use the between operator, and you did not use the between operator. You just
No,
took a shortcut.
I use the between operator.
Really, I didn't see it. I
Okay, it
mean,
was
your
like
query is literally still on your screen.
no, it was like this. It was the length. I already knew where to put it. Okay, let me just do it. It was like this.
Run, let's see.
This is the result.
Don't you want to run again?
It's not running. I don't know. It's not displaying anything.
Love it. Are you there?
Yes, I'm here.
All right. So we can move forward then.
Okay.
So under it, it says that that's A. Do the same, but get clients whose first name contains at most 5 characters. So you just have to play with what is there in the where clause.
Even I did it before wiping this one.
Oh, okay, that was the so okay, then it means what you had was correct. So let's move to number 6.
Okay. Yes. I'm done.
Okay. So you're getting customers whose first name starts with bra using a case insensitive search. And last names do not end with bra. All right. Let me see all that you got. Okay. This is fine. That's really good. Love it. Okay, so moving forward, you're talking about Boolean values. So in Postgres, you can have one of three values, true or false, and you can also have null. Null just basically meaning that the absence of a value. So in Postgres, you can use either true, T, mm, formatting issues. Anyway, you can use either true, T, yes, Y, 1 to represent true, right? And then for false, the same thing, false, F, N, no, and 0 to represent false. Now, we move forward to define a Boolean expression as an expression that evaluates to a Boolean value, right? An expression that evaluates to a Boolean value. So, for example, the expression 1 equal to 1 is a Boolean expression that will always evaluate to true because it's 1 equal to 1, yes. But then if we had the expression, say we had the expression 1 equal to 0, what would it evaluate to?
No.
1 equal to 0, what would it evaluate to? I not get.
You said if it's 1 equals 1, it will evaluate to yes, right?
Yes.
That's and I said 1 equals to 0 will evaluate to no.
Okay, I had no. I wanted to be sure. All right. So yeah, we'll evaluate to no, or preferably it will evaluate to false. So that's correct. So let's look at what we have here. Okay. So without running a query, right? What is the output of the following line of code? What we have here. This thing doesn't want me to select. Get select 1 equals 1 as result. What will be the output?
Will be true.
All right, let's run it and see. Let's easy admin on my end. Okay, so it said select 1 equal 1 this result, right? Okay, so you got it right. Let me try. Okay, control plus increasing a little. Okay, so let's move forward. Now, in the where clause, the and operator has this syntax where expression and expression. You have already used it and you've already seen how it's written, right? In a similar manner, the or operator will also have the following syntax where expression or expression. If there are more things, you keep having expression and so on and so forth. Now, if you had to if you had a specific case, you can combine um and or, right? Let's say you have to select something from some table. Let's call that table X. We don't know what the table is. And then we're saying that, okay, where maybe first name, for example, is equal to John, or first name is equal to Mary. This is the condition that must be there. Then we now come and say and age must be 35. We've combined the and the or operator, right? But take note that I made use of parentheses here. Why? Because if I took out this parenthesis, if it looked like this, it means I'm saying that, in fact, how would this be evaluated without the parenthesis? What do you think?
Well, with the parentheses, they all will first evaluate, and
Mm-hmm.
then with the and,
Good.
but
So with the
without the
parenthesis. This is treated as one expression, right?
Yes.
Yes. Okay. And without the parenthesis, what happens?
It's not treated as one expression.
So how will it be evaluated? Let me remove it. Let's be more visually appealing. This is okay. No wonder my mouse is low. I've been wondering why I've not been able to select. Okay. So yes, if you were like this, how is it going to be interpreted?
It's going to be first name John or maybe ish.
No, but you're
Mm.
taking so long to answer.
Well, I don't know how to word it, but I just know that it's going to be messy.
It's going to be messy. It's a very vague explanation. But I'm going to put this on your channel, and you can think about it later on.
Well, I've done truth tables, so I understand the concept of putting the parentheses before the and.
Okay. All right. So let's move forward. Let's look at this. So we have this exercise from the film table in the DVD rental database. Get all films that have a rental rate of 0.99 or 2.99. So wait, how are we going to do this? Guide me. We already know that there's a film table. You had set up this DVD rental database, right?
Yes.
Okay. So we know that there's a film table. Let's look at the columns. Film ID, title, description, release year, language ID, rental duration, rental rate, which is what we're interested in, right? And the question says, from the film table in the DVD rental database, get all films that have a rental rate of 0.99 or 2.99. How are you writing it?
Okay. Use where statement.
Where clause, all of this, you see this semicolon
Yes.
represents one statement. And then what you're talking about is a where clause.
Okay. The where
Mm-hmm.
then you
So what
display
do you
the
think?
rental rate
Mm-hmm.
equals to 0.99
Mm-hmm.
or
Yeah.
rental rate equals to 2.9. But you said that you want it to be more readable. So why don't you put the oil on a different line?
Excellent. All right.
Yeah.
It's a lot of information. Let's just take the film ID and rental rate. Okay. Okay. Your result is correct. And to answer your question, if you put a comma there, it proves a syntax error because this is not a SQL rule. This does not follow the SQL syntax. Okay. Now the next exercise from the same table, that's from the same film table, find all fields that have a length above 180 and a rental rate less than 1. So let's look at this film table again. Let's just look at the columns. Or let me do it on another line just in case you may want this query. Okay, let's look at the columns again. Release year, rental duration, rental rate, and length. So yeah, we're not going to use a length function, right? We're just
Yeah.
using the actual column. So let's go back to the question. It says Find all films that have a length above 180 and a rental rate less than 1. So how are we writing it?
Oh, I should answer.
Yeah.
Where
Mm-hmm.
length
Mm-hmm.
is uh the one on the right. Okay, greater than 180
Yes.
and rental rate
And
is
rental
less,
rate.
is less than one.
Okay. This is good. This is good. So I'll
But I
just
want to see what happens when I say where rental rate is lesser than one and then length is greater than 180.
if there are results for it, then it's going to fetch them. But let me put these columns, let me run and see. Right?
Okay.
Okay. So less than one, yes, all of this is less than one. Greater than 180, all of these are greater than 180. So you said you want to see for when the rental rate is what?
Like when the rental rate comes first before the length.
What do you think is going to happen?
I don't know. That's what I wanted to say.
No, love it. Think about it. Try to evaluate what the result will be before even running. What do you think is going to happen? I know you're just waiting for me to run.
Because you're already there, you
No,
can just click on the button.
no, but I want you to think. What do you think the result is going to be? It's an operator. It's and either way. Take note of the result there. Just try to mark them a little. Mm-hmm. Let's run. Has anything changed? No.
No.
Why? Because the AND operator behaves
Ah,
just like when you're doing multiplication. And
yes.
multiplication is what? Commutative. So A times B is the same as B times A.
Okay.
Okay. So let me see what is next. Okay. Now in PostgreSQL, we also have the limit clause, but it's optional. It's optional when you're using the select clause. So limit clause just limits the number of rows that we get, the number of rows that are returned as a result. This is the syntax: select from, maybe if you have where, right? Then order by, and then the limit. So take a look at this, for example. Let's say that from these results that we got here, right? We want to see only um, okay, let's first of all start. We want to see only maybe the first two in ascending order. What are we going to do? We're going to add the order by clause, right?
Yes.
Order by, now I can use the column alias. So order by film length. Let's run first and then see the result. Great. So we have 181, 181, 181. And we're like, you know what? We just want to see the first two results. Just want to get some high level overview. So I'll just write limit 2 and it gives me that, right? If it's one result that I wanted to see, I'll write limit 1. If it's maybe 10 that I want to see, I'm going to put it there. Okay. So that's how the limit clause works. But then there's also something called the offset. So the offset, anyway, let's look at it here. Let's look at this note first. So they said that if you use limit, if you use the limit clause and the value that you put there is 0, the query will return an empty set. It doesn't give you anything. And then you'll be wondering, oh, there's zero. Why doesn't it just return everything? No. The moment you put zero, you're telling you that, okay, I don't even want to see anything at all. You get it?
Yes.
But then if you set it to null, null is going to return the same result set as though the limit clause was not even there. Why? Because null, again, you can interpret it like this. Null is the absence of a value, right? So it's basically like saying,
Live streaming is on.
okay, so this is what happens when you put zero and when you put null. Okay, so let's move forward. Now there's also the offset, right? Now offset is saying that if you desire to skip n number of rows before returning the row count number, then you can make use of the offset clause placed after the limit clause using the syntax as such, using this. So what happens now is that, okay, I'm saying that let me add another column here to make this look more interesting. I think we had something like title. Okay, nice, nice, nice. So, yeah, this should do. Okay, so now I'm saying that I want to view, maybe we should reduce this so that we actually get more rows, right? Let's say 100. Let's see. Yeah, we have about, oh, now this is too much. Okay, but either way, we have 203 rows, right? Okay, now we're saying that from these 203 rows, we want to see maybe just the first 20. We already know that the limit clause is going to give the first 20. But then take note of the results. Take note of the results before we change that to 20. So when it's sorted, we have what's this? Ghostbusters, runner, whatever, roof champion, chocolate Harry. These are some strange film names. Okay, so let's end here. Right? So we have these four films. This is how the results are. So if I say that I want to limit my result to 4, I'm going to get just these films, right? But then if I come and say offset 1, what do you think is going to happen? Do you see what it did?
Yes.
What did it do? What happened?
I just saw it.
So tell me what you saw. What happened?
The rules reduce.
No, we still have 4 rows here. See, 1, 2, 3, 4. Let me take this away. Comment this. What's the first film? Ghostbusters, right? The
Yes.
length 101. Roof Champion, the length 101. Chocolate Harry, 101. And then Rona Madigan, 101. This is when we do it like this. But then the moment I come and say offset 1, so the moment I come and say offset 1, look at the result. Ghostbusters, 101. Roof Champion, yes. Chocolate Harry, yes. But then something changed. Why?
Yes, the last one
Why did it change?
because you offset one.
So what will happen if I put offset of 2?
The last two rows to change.
Okay, nice. So let's take out this order by clause. Let's take out offset for now. Let's get the first 4 rows. So we have Alamo, Alaska, Date Speed, and Amadeus. Okay. Now if we say limit of 1, sorry, offset of 1, and we run, what has happened? What the offset actually does, love it, is that it helps you to skip. You're saying that, okay, I want to skip a particular number of rows, right?
Yes.
Maybe if I have a use case, a proper use case is pagination. So do you know what pagination is?
No.
Okay. When you're on a website, I think even here on ISC Learn. So when you're on a website, okay, yeah, I think it's displaying, I can't recall, maybe it's 10 assignments per page, right? But if there were more assignments, let's say 20 or 2000, we cannot display all 2000 assignments here, right? So we now split it into pages, maybe 10 per page or 100 per page. So that splitting into different pages now is what we call pagination. And you've seen it in different websites, right?
Yes.
Mm. You've seen it in different websites. Okay. So now look at what I was actually trying to demonstrate here. I've only used it to joins. So look at what is being demonstrated here. So the offset clause is evaluated. Okay, note that the offset clause is evaluated before the limit clause and it's useful in pagination as I just mentioned. So let's say a page, you have a certain page number, like page one, right?
Yes.
And then you have a limit, the number of rows to return. You already know that. And then you have the offset, the number of rows to skip before even returning that result, right?
Yeah.
Now, if you were to use this in pagination, if you were to say that, okay, my query or what I want to get is 1000, but I cannot show all 1000 on a page. On one page, I want to show maybe 20 each, or I want to show 10 each or 50 each, all depends on your use case. What are you going to say? The offset now is going to be calculated as this. You're going to say page minus 1 times the limit. So limit is what I want to display, right? How many items I want to show. So let's say on a particular page, on each page, I want to show 50 items. So my limit is 50. Okay, now I'm going to say for my offset to know the number of items to skip, I'm going to say, okay, depending on the page that I'm on, right? Depending on the page that I'm on, if I'm on the first page, that's page one, right?
Yes.
1 minus 1 is going to give us 0 times, let's say, the limit of 50, right? Which is also going to give us, when you multiply, it gives us 0. So we're basically saying that don't skip anything, start with the first 50 items. So it's like saying offset 0. So an offset of 0 is equivalent to the offset not even being present at all. Now, let's say that I'm on the next page now, page 2. I still want to display 50 items, but the 50 items should not be the same as the first 50 items from my query result. It should now be the next 50 items. So meaning, let's say 51 to 100, right? So what's going to happen? I'm on page 2. So I'm now going to have in my offset 2 minus 1, which is what? 1, right? Limit is still 50. 1 times 50 is 50, and we say this is our offset, meaning that on page 2, skip the first 50 items and show me the next 50 items. Do you understand?
Yes, sir. Yes,
The,
madam.
yes, so it's going to continue like that, and you're on the software track. So this is something you should do or you should understand. Okay, so I've already said that the offset of 0 is equivalent to the offset clause not even being present at all. And then you should remember that PostgreSQL stores rows in a table in an unspecified order. So you should always use the order by clause to control row order. Same thing here, like maybe with the assignments. If we're just returning the assignments anyhow, it's maybe going to be scattered. So now we're ordering by, let's say, when it was created, right? Or maybe by the due date for you, so that it's also easy for you to pick. Not that we just return it anyhow. The one that is due today is at the bottom. The one that has even been submitted as passed is at the top. It doesn't make sense, right? So we use the order by clause here. We have exercises. Wow, this is a lot. Okay, we have exercises. Just, I think you can just do the first three, right? And then do the rest later on so that we can maximize time. Are you there, love it?
Yes, you said I should do them.
Yes, do the first three. Then you can do the other ones later so that we maximize time.
Okay. Excuse. This is number one.
Okay. Find the first five fields from the theme table sorted by theme ID. Yes, that's correct. Yes, that is also correct. Love it, are you doing it? I can't see your screen. Okay.
I had a network issue.
It's all right.
Okay. I'm done.
Okay. Fetch the top 10 most expensive films by rental rate. Just get the film ID and rental rate. Let me see. This is just too much. No, I mean like the columns that you're selecting.
Wait, but I'm using a descent to sort from highest to lowest now, and then the
Yes, I'm
limited.
saying that the column, don't select star. Get just film ID and rental rate so that I see.
Okay, that's why I'm wiping it now to just display just ID and.
No, no, no. Love, you're not understanding. You've done the exercise, but instead of having select star, just do select film ID and rental rate.
Oh, okay,
Give me a moment then.
okay,
I love it. Okay, I'm back. So let me see. You've done the first three exercises. Okay, now let's look at pattern matching. So Postgres offers two wildcards for pattern matching. So we have this percentage sign, which you already know and you've already used. So it matches any sequence of 0 or more characters. But then you have the underscore sign and it matches any single character. We've already seen how to use this in the examples that we had. Let me see. This is the syntax here. And then let me see. If the pattern does not contain, okay, we've already actually discussed all of this. But then the new information that is being introduced here is this other wildcard underscore, right? So while percentage is doing 0 or more characters, underscore is matching any single character, exactly one character. So let me see, these exercises here are not many. So I think you can do all of them. They say find customers whose first name contains ER. So using the DVD rental database, there should be a customer table. So find customers whose first name contain ER.
Okay. I've done the first one.
Let me see. Mm-hmm. Yes, it's correct. You can move to the second one. You need to actually explain it without running. Explain.
Okay. Um, the percentage in the percentage below inside this code.
Mm-hmm.
Okay, describes any number of characters that should be displayed, and then the like operator is used for case sensitive match, and then the I like operator is
Yes.
used for case insensitive matches, and then the underscore.
Love it. You're not, I'm saying you should explain this query.
Yes, so you're selecting the first and last name who from the customer table.
Mm-hmm.
Okay, where you're going to display the first name containing her, like any names starting with her.
So what does this underscore before the her do?
It means that you should display uh, at most one character.
Yes. So it should contain her, but there must be one character in front of the her, right?
Yes.
Okay. And then at the end, any number of characters, zero or more. So when you're explaining, you actually need to be detailed like that.
Okay.
All right. So let's look at the next exercise. Find all customers whose first names do not begin with Jen. So you can go ahead and do that one.
Okay. Okay.
Okay. Let me see. All right. That's good. Okay. So I like how you've already taken initiative to work with like, I like, and then using the not operator in front of it. Now, let me see. Instead of writing like, there are some operators that you have here that will have exactly the same functionality as writing this text. But this text, of course, is easier to remember, easier to work with. So this is just, yeah, like, okay, nice to know, not necessarily that we should use it. I always recommend using the actual text itself, the actual word itself. Okay, so check out these exercises here. These two exercises, find addresses in the address table where address to is empty, address to is a column. So do that exercise.
I'm done.
Nice. Find addresses in the address table where address to is not empty. That's question number two.
Okay. I'm done.
Nice, nice. All right, so there's an assignment here for you and also some additional resources. So I expect that we should go through this actually. Um, I spelled this wrong. It's supposed to be fetch. Put down here, fetch. Anyway, you get the link. But then I expect that you should go through all of these so that it helps you understand more and learn more about the language.
All right.
All right, so let's move to the next lesson. SQL intermediate concepts. Okay, I'm trying to send an announcement on Discord, so just give me a moment.
All right.
Okay, all right, so let's look at joins. So when you talk about joins, take a scenario where, let's say, you have a customer table and these customers make purchases, right? Or they make orders. Let's say it's a restaurant. So you most likely have an orders table as well. The customer table has information on each customer, like their first name, last name, address, email, phone number, and all of that. Now, the orders table would have the order ID, the customer ID, and maybe the order date, delivery location, and all of that, so that we can be able to get information about an order. What is the customer ID doing in the order table? So we can know which customer made this particular order, right?
Yes.
Now, let's say that we want to get the list of customers who have made orders. When I say the list of customers, I don't mean the customer ID, right? I mean like their first name and last name. And we also want to get the orders they made and maybe the delivery location, for example. So now you see that we're trying to get data from two different tables, from the customer table, from the order table. So far, we've been fetching data just from one table. So if we want to work with more than one table, how do we do it? That is where joins come into play. So a join, as it says here in the notes, is used to combine columns from one or more tables based on values, based on values, based on values in what we have, what we call common columns. So when you're joining two tables, right, there must always be a common column that you're joining on. So take for example, if you want to get all orders of customers, you need to join the customer table and the order table using the customer ID column or using the customer ID field, because why? That is the common column between those two tables. That is what relates those two tables, right?
Yes.
Okay, nice. So let's get into it. So there are different kinds of joins. We have the inner join, the left join, the right join, full outer join, cross join, lateral join, self join, right? And we're going to take a look at them. So let's share. You're no longer sharing your screen. Share your screen and do this. So create two tables. one called fruit A and another called fruit B with the following columns.
Okay.
Live streaming is on.
I'm done.
Okay, so we now say that using the select statement, fetch all fruits from both tables and specify one at a time, just so you get the results. Lovett, are you there?
Yes, but I don't know why it's not displaying. I want to select
Did you run
each.
the insert query?
Yes.
No, no, no. Just put your. Okay, okay. Go ahead. It's okay. Go ahead. Have you succeeded? I switched my screen.
Uh, please, what you say?
I'm asking if you've succeeded.
No, I'm trying to rectify the problem in the insert. Um,
Okay.
I don't know why it's not displaying. I don't know what's wrong.
Mm. Lovett, sorry, I did not get you.
I
If you're
said I
post
don't know what is wrong.
relation fruit A does not exist, meaning that the table has not even been created. So go back up to your create table statement. Yes, your cursor is there, right? So run it, create table. It was successful. Then come down now to your insert into of fruit A and run. Let's see again. Great. Now go down to your select statement. Select star from fruit A. Let's see. Run it. Let's see. Are you there? Your screen seems frozen. Robert, are you there? Louis, are you feeling much better? Um, Hello, Lovett. Are you still there? If you're talking, I cannot hear you.
Hello.
Yes, Lovett.
Okay.
Oh, what's happening? I said you should now come and use the select statement to view everything in your fruits A table.
It's just that today I'm not using the Wi-Fi, so the my bundle keeps on. I keep on renewing my bundle.
Oh, okay, okay. So, okay. When
Live
you're ready, let me know.
Okay. Okay, I've done it.
It's fine now, right?
Now
I'm
I've
saying
just
select,
okay. Let me select.
yes, from fruits A. Okay, so it's good now. Do the same thing with fruits B. Create it, insert the values, and run.
Okay, I've selected from
Okay,
food.
that's for fruits B, right? Okay. So now we can move forward. We can move forward. Okay. So going back to the notes, can you still see my screen?
Yes, I can see your screen.
Okay, nice. So going back to the notes, we want to look first at the inner join. So the inner join has the following syntax. So in the select statement, you still have your select list, right? But then look at the from clause. We're saying that from the first table, table one, we give it an alias as T1. And then now we say inner join with what? With table two, give it another alias T2, such that we use the join condition In fact, where T1 and T2 have matching columns, then the rest is standard SQL that we know. So this Venn diagram here represents what an inner join does. So you have data in a table, table A. You have data in another table, table B, right? Now, when you join those two tables, what you would fetch from there, the result that you're going to get is what is common to those two tables, hence intersection. The inner join is just like um, it's just like using um, it's just like intersection when you're working with sets. So let me see. Let's go to the DVD rental database and let's take a quick look at the customer table and then the payment table. So let's start with customer. Okay, so the customer table, it has their ID, the store ID. This is something else, maybe for another exercise. First name, last name, email, address, ID, this active boom, maybe registering whether a customer is active, create dates, last update, and so on, right? Now in the payment table, let's look at what is there. So we have the payment ID, we have the customer ID, we also have the staff ID. Let's say it's the staff that was processing this specific payment for a customer, right? We have the rental ID, and then we have amount and payment date. Amount, that's how much was paid, payment date, the date that the payment came in. So let's say that I want to get customers, right, who have made um payments, all customers who have made payments. You know that in here the customer ID will be repetitive, right? Like here we have 365, 365, 365. So, but the payment IDs are different. So let's say 365 is a customer Lovett. Lovett bought something at 499, came again and bought something at 299, and then at 099, and so on. This is how it actually happens in the real world. Okay, so now let's say that we want to get all customers who have made payments. All customers who have made payments. What are we going to do? Yannick, just close the door. So we now have to join the customer table with the payment table, right?
Yes.
With the payment table, but then we must provide a join condition or what we call a join predicate. So you want to join customer and payments using what you need. That's where you need those matching columns, right? So let's look at the customer table again. Customer ID is there in the customer table, of course, and then in the payment table, we have payment ID and customer ID, right? So now we'll now come and say on customer dot customer ID is equal to payment dot payment ID. So I want to get everything from these two tables where these two conditions are the same. So customer ID in the customer table must be equal to, must be equal to customer ID in the payment table as well. Does this make sense so far?
Please take it all over again.
So with the inner join, right? In fact, with joining normally, I told you that you need to join using matching columns, right? If you want to take data from one table and another table, there needs to be something that is common between those two tables. And in this case, it is a column. Is that part clear?
Yes.
All right. So now when you're writing everything down, this is how it's supposed to be. This is the syntax. Now when you're joining, you need to specify the kind of join that is actually happening. Thank you. Yeah. Fine. So you need to specify the kind of join that is actually happening. Is it an inner join? Is it an inner join? Is it an outer join? Is it an inner join? Is it a left join? Is it a right join? Right joins and left joins are all outer joins, by the way. And then there's also the full join. Now, depending on what you want to do, now with the inner join, I'm saying that it works like when you're doing intersection with sets, right? So you have one table, you have another table. The data that you return is only the data that is common to those two tables. Do you understand?
Yes.
Okay. Now, I'm just writing the syntax there. What I'm showing you now is just the syntax. So now I want to do an inner join. I want to get all customers who have made payments. All customers who have made payments. Visualize it like this first, a notepad. When you have your customer table and you have all your customers there, these are their IDs. You have customer one, two, three, four, five, and six, right? With all their information. In the payment table now, perhaps only three out of these six customers have bought. One maybe bought something, two bought something, one bought something again, three bought something, two bought something, one bought something, right? So now you're saying that it's close the door, people. Lovett, please give me a minute.
Okay.
Sorry, love it. Okay, are you there? Love it, are you there?
Yes, I'm there.
All right. This class ought to have ended at 3:30. So I'll just explain these inner joins, right?
All right.
And after explaining the inner joins, tomorrow we'll have another session, same time. So I expect that you should go through like everything up to the point of where these notes end. Like just read as much as possible. Go through everything on joins so that tomorrow we can do group by. If you can even enter, this will be good. So that we can do group by the having clause, and then we also look at CTEs. So this way I've ended with the on-site guys. When we meet at that level now, all of you will be required to do self-study for the remaining concepts. So let
Okay.
me round off with inner join, then we can call it a day. I think you have class with Yannick later, so you should also get some time to rest. Okay, so I was saying that with the inner join, right, is the same as this intersection here. Okay, I was even giving an example here. Okay, so let's say we have our customer table like this and the payment table like this. So there are many customers, but not all customers make payments, right?
Yes.
So now let's say that you want to get, let's say that these customer names, of course, are accompanied with their first names. John, Mary, Peter, Judas, Paul, and I don't know, Elizabeth. Okay. So let's say you want to get all customers who have made payments. Perhaps your first instinct, right, will just be to come and get all customers, maybe customer ID from the payment table. This sounds okay, right? It's straightforward. And if you want only the unique values, right, the distinct values, you make use of the distinct keyword here, right? But then what happens when you now want to get their first names as well? Now for today's something, now come and do an inner join. The inner join will say, okay, from this table, let me write, let's see customer. Let me just finish the query. Customer on customer dot customer ID is equal to payment dot customer ID. Okay, now what you're basically saying is that from this my customer table, I want to get all customers who also exist here, meaning that you take the two tables and join. If one is here and one is here, return the result. If two is here and two is also here in this table, return the result. If three is here and three is also in this table, return the result. That's what the inner join is doing. So the intersection is not going to take everything from here and then maybe if it does not find the match, it now becomes a problem. No, it's only looking for what is common based on this join predicate that we provided here. These matching columns, right?
Yes.
Do you understand?
Yes, so far.
Okay. So now, if I'm saying that, okay, I want the customer ID and then maybe the first, right, is going to be because they are the only customers who have bought here, who have made payments, they exist here. But it's not going to give me Judas, Paul, and Elizabeth. Why? Because I'm doing an inner join. But just to give you, just to throw more light, if we're doing now a left join, this is how a left join is. The left join will take everything, whether or not there's a match. Then you read that on your own and further understand. So let's focus on the inner join. Let me go back to PG admin. So this is it. This is basically what we have. Now, this star here now, what's going to happen with this star? It will not only select everything from the customer table, but it will equally select everything from the payment table. Why? Because we're joining two tables and we're like pick everything. So let me run and then you get to see. It starts with the first table, right? Which is a customer table, all the columns. Then it comes now with the next table. Starts now payment ID, customer ID, gets all the columns. But is this really what we want? No, right? It's just too much data that we're fetching for nothing. So let's say we may want the customer ID, but then the customer ID exists in both tables, right? Customer and payment. So which table now are we getting it from? Let me say we want customer ID, um, first name with the last name as the full name. And then we also want, say, the amount that is spent. Let's run. There's an issue. Column reference customer ID is ambiguous. Why is it ambiguous? Because customer ID exists in both tables, right? So now it doesn't know which table it should be picking from. Do you see how we did this join predicate? We came and said on customer.customer ID is equal to payment.customer ID. So we're referencing the tables here, right? In a similar manner, if I want to pick this customer ID from the customer table, I should come and say customer.customer ID, right? And it's going to be okay. If I now want to say, okay, I want to pick this customer ID rather from the payment table, then I'll come and say, okay, payment.customer ID. Now, these other ones, I don't do any prefixing with the tables. Why? Because this amount column exists only in the payment table, and this first name and last name columns exist only in the customer table. If they were in both tables, I'll now need to specify, right?
Yes.
Okay, but then look at the notes. Look at what the notes say. From table 1 as this, inner join table 2 as this. So they actually gave the table an alias. In our case, we did not give it an alias. That's why we are using the full table name. But then this is just too long to write. So I can now come and say as C, right? Then I come here and say as P. Or even if I remove this as, it's still the same thing, right?
Yes.
Okay. But I like readability. It's always advice. Meaning that I can now come and change this to C the customer ID equals P the customer ID. And if I run this, I get the same result. You see, let me even remove this amount to get giving us duplicate data. Still have duplicates. How do we solve this issue of duplicates?
Distinct.
Distinct, where do I write it and how? Guide me on how to put the distinct in this query to remove all these duplicates. Lovell, your mic is muted.
Can you hear me now?
Yes, I can hear you now.
Okay. Select distinct.
Like that.
Mm, no. Yes, like that, but not closer to distinct.
So make me understand, where is it supposed to be?
It's supposed to be. No, it's supposed to be there.
Okay. Let me run, let's see. Nice. Let's order this. See by the customer ID. Be sure. Okay, nice, nice, nice. No duplicates. Okay. So this is how the inner join works. Going back to the notes, let me see. So I even jumped to the second exercise. Um, okay, but then I just did a part of it. So look at this exercise here that we have. Get matching fruits from the fruits A table, from the fruits A and fruits B table. So of course you're supposed to use the inner join, get matching fruits. Do it, let me see. I'll leave this syntax for the inner join here so it can guide you.
Yeah, I'll need to connect my laptop.
All right. So we'll just do this exercise and we call it a day. The rest of them you can do it in your personal study time before tomorrow and go through the rest of the notes.
It looks like my table did not save.
You mean your query?
Yes, I'm
If
creating
you
a
want,
table for the fruits.
oh no, 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 but it's okay. The tables have already been created, even though you did not have the query saved.
Oh,
Just
okay.
need select start from fruits A and C.
Mm, okay. Excuse. I'm done.
Okay, let me see.
I use aliases.
Okay, okay, okay. So that's okay. That's fine, Lovell. So we'll call it a day, and then, like I said, continue with the rest of the material, and then tomorrow when we meet, we'll continue. So tomorrow I'll be taking group by having and CTEs. So make sure to go through everything on joins. If you have questions, put it on Discord. The on-site guys have already done this, so they can be of much help.
All right.
Okay. Goodbye, then.